Phase 2 is the redo phase. We're going to repeat history to reconstruct state at the time of crash. We're going to reapply all updates, even the updates of aborted transactions, and we're going to redo all the CLRs. Many recovery protocols are tempted to not redo the actions of transactions that didn't commit. This is a mistake. Transactions can be interleaved in various ways that are quite subtle, and without getting into details, if you don't repeat history, including the aborted transactions, life gets very complicated and transaction recovery schemes tend to have bugs. One of the key innovations at ARIES was to repeat history completely. It makes life much simpler. It allows for the recovery protocol to be extended in many ways, and it's just really very clean. Okay. So we're going to scan forward from the log record containing the smallest recLSN in the dirty page table at the time of the end of analysis. Why start there? Well, remember, what is the recLSN? It is the log record that first made this page dirty. So the oldest recLSN is the oldest update to a page that could have been in the buffer pool at the time of crash. Okay? Nothing older than that could have affected the buffer pool at the time of crash based on the recLSNs that were in the checkpoint record. So anything before that time was definitely reflected in the database. The smallest recLSN in the dirty page table marks the point in history where it's possible that updates need to be redone. And so we start from there. For each update log record or CLR, so we're going to scan forward from this recLSN. And for each update log record we see, or CLR that we see, if it has a given LSN, we redo the action unless one of the three things is true. So in general, think of redoing things always. But before we redo them, we're going to check the following three conditions and avoid redoing them if any of them hold. These are conditions that tell us that the thing has already been done and doesn't need to be redone. The first condition is that the affected page of this log record is not in the dirty page table. All right? If it's not in the dirty page table, then somehow it was flushed to the database already, and so we don't need to redo it. The second case is that the affected page is in the dirty page table, but it has a recLSN that's later than the current log record we're looking at. Okay? And in this case, what's dirty about this page is something that happened after the log record we're currently looking at. And the log record we're currently looking at has in fact been flushed to the database. The third possible case is we actually go down to the database to apply the redo. So we actually do an IO in the database, but the page LSN in the database is greater than or equal to the LSN we're currently looking at. In that case, we know that the database page is in fact from a later time, a later update than the current LSN, and we don't need to redo the current LSN because it was already done. Outside of those three cases, we redo the action. And the way we redo something is we simply reapply the redo information in the log record. We set the page LSN of the page we're updating to the current LSN we're redoing, and that's it. We don't have to force the page to the database. It can sit in the buffer pool, okay? And we don't have to do any additional logging. So redo simply updates the page in the buffer pool. We talked on the previous slide about three scenarios when we do not redo. Let's go through how each of these could have happened. So remember, we're going forward from the smallest recLSN, record by record, looking at each record. Given one of those update log records, if the affected page is not in the dirty page table, then we don't redo. How could that have happened? Well, this page was flushed to the database and removed from the dirty page table before the checkpoint. Then the dirty page table was flushed to the checkpoint, all right? And therefore, this page isn't in the dirty page table. It's been flushed to the database, and we don't need to redo it. Okay, scenario number 2. The affected page is in the dirty page table, but it has a recLSN that's greater than this LSN. How did that happen? Well, again, this page was flushed to the database and removed from the dirty page table before the checkpoint. So it's no longer in the dirty page table in memory. Then it was referenced again, read back from the database into the buffer pool, and reinserted in the dirty page table with a larger recLSN than the LSN we're currently looking at before the checkpoint. And then the dirty page table was flushed to checkpoint, reflecting that second update to the page. We're currently redoing the first update to the page, but we know that that's already on the disk because there's a later recLSN for this page in the dirty page table, so we don't redo this one. It's already in the database. Final case, we get down to the database and we are about to apply our redo, and we see that the page LSN in the database is greater than or equal to the LSN we're looking at now. How did that happen? Well, this page has simply been updated and flushed to the database, stolen, after the log record we're looking at. And that could happen at any point for any number of reasons, because the buffer manager can be writing things to the database asynchronously. So this page was stolen, it was flushed to the disk, that's fine, and our update has already been reflected.